Right, yeah, 10, just a little recap on SOHCAHTOA and right-angled trigonometry, which is our new topic. Started today, and this is a bit of a recap. It's been covered before, but it's not straightforward. So just going to go through and spend a day or two going over some of the results, the theorems, and things that you've established in the past. Okay, so nothing new in this. I just wanted to spend 5 minutes just going over a few things, so that tomorrow when we get to class, perhaps we can get on with the questions, the exercises in the textbook, and the work requirements on those. So if we just have a look at right-angled trigonometry, which is what we're doing, is sort of that branch of trigonometry and triangles dealing specifically with right angles. And we've just opened up the screen here. These are the notes from today. But Pythagoras' theorem is one of the options when we've got a right angle triangle. We're looking at solving a problem to do with a right angle triangle. The Pythagoras' theorem deals only in sides, doesn't deal with angles, so it's just specifically c squared equals a squared plus b squared, and doesn't help us out if we've got an angle that we're working with rather than sides. So if we work down the page here and bring in an angle, and this is really what we talked about today, and perhaps just need to check that your notes are good on this, and that is, here's a right angle triangle. The first thing we need to look at when we're working with SOHCAHTOA and working with sine, cos and tan in order to solve some problems is know exactly what the sides are called. So a hypotenuse is always a hypotenuse. It's the longest side. It's opposite the right angle. The other two sides, the opposite and adjacent, just depend on which angle we're talking about. So if it's the angle up here that I've indicated on the diagram, then the opposite angle is the one that's straight opposite that. I've labelled that there, and the adjacent side is the other one that's just adjacent to that angle. So once we've got all those sides, we understand the orientation of the sides of the triangle, we can work out whether we're going to go for sine, cos or tan when we're solving a problem. And up here I've just decoded SOHCAHTOA. Sine equals opposite over hypotenuse, cos of the angle equals adjacent over hypotenuse, tan equals opposite over adjacent. That's all there for you to take in. Then we just do a couple of examples here. In this first example, we've got a right angle triangle. We're trying to find this side here, x. We've been given that this angle here is 65, this side is 8. That's all the information we've got. That's the hypotenuse there. This angle, the side we're trying to find is x, which is the opposite side. That's the opposite side, and this is the adjacent side, so opposite over adjacent, that's tan. So we're working with tan. So tan 65 equals x over 8, and therefore x is equal to 8 times tan 65, which we put into our calculators, get 17.2. Remember, we can use the solve function on the calculators to calculate the value of x also. Let me go, if I look at an example here where x comes up underneath in a fraction, so again we just have to identify firstly which sides we've got. This is our reference angle 31, that's our opposite side. There's nothing there, so we'll forget the opposite. There's 15 here, that's the adjacent side, and the hypotenuse, adjacent and hypotenuse, well that's it's cos, so cos 31 equals 15 over x. Remember, it's adjacent over hypotenuse, so it's 15 over x. Looks like this. And then when we've got x underneath, and that's the unknown, we firstly have to take it out, so it's x cos 31 equals 15, and then we need to divide both sides by cos 51, so we end up with x equaling 15 divided by cos 31, which when you put that through your calculator you get 17.5. Final example here is just to work out what this angle here is. We're given a couple of sides. Now the sides we've been given are the opposite and the hypotenuse. Now the opposite and the hypotenuse in SOHCAHTOA, that's sine. Sine of this angle will equal 7/12. So we get our calculators out and we just put in, we'll do this one, sine inverse 7/12. So we go, we put in sine minus 1, sine minus 1, and we put in 7/12 in there, and then hit enter. It won't work it out just yet. We need to hit control enter to get 35.7 to 1 decimal place, which is what it is there. They're the examples that you're going to see. They're the types of questions you're going to see. Different information. If you're trying to find an angle, remember you're always this 35.7 was found by taking sine inverse 7/12 and getting 35.7. So that's when you've got two sides, you're trying to find the angle. If we've got the angle and we're trying to find a side, well, that's a bit more straightforward example where you're just saying, say, cos 31 in this case, 15 over x, working that through. So x is equal to 15 divided by cos 31 when x is underneath. It's 15 divided by cos 31. When x is on top, like it is here, it's 8 times tan 65. If these were switched around the other way, it would be 8 divided by tan 65. Okay, so we should be right now, hopefully, with those examples and this and what we did today in class, to have a good session tomorrow on exercise 4A and 4B. Get some work into us. I can help those people having a bit of trouble. Make sure you bring your calculators, please, your laptops, and also the work requirements for the holidays, the holiday homework that I set you. I didn't get around to collecting that in class today. Maybe that's with the extra day. Hopefully you'll be organised and you'll have that for me tomorrow. So please remember to bring that in also. Alright, I'll see you then.